just by way of a reminder, or probably a reminder if you've watched the tutorials, I think you probably have watched, I just want to remind you that we kind of have three energy systems. We have one that's called the phosphagen system. We have one that's called the lactate system, sometimes called the lactic acid, or the glycolytic system, the lactate system. And we have one that's called the aerobic system. And just remember that aerobic system one, it incorporates the oxidation of both glycogen, but also fats. Okay. Now, with that in mind, I want to introduce you to the definition of energy continuum, a sort of a definition that probably doesn't sort of just skip off the tongue. Energy continuum, what's that? And we're going to say it's the relative contribution of all three energy systems to energy transfer. So just to be clear on this, at all times continuously, these three systems are continuously resynthesizing ATP all the time. But of course, at any one time, this one might be doing more this one or this one. And what we're going to say, therefore, is that we have a predominant system. One system effectively becomes the predominant. That's not a good colour. One system will become the predominant system at any moment of time. And that predominance is based on the intensity of the exercise or non-exercise, and also the duration of it. So think about a 100-meter sprinter legging it down a track. Very high intensity, but low duration. That is going to make, in this case, for example, the phosphagen system, the predominant one for those moments, and we'll come back to the details of that in a moment. Now, this will lead us to do some graphical illustrations. So let me get my ruler out, and let me try and get this as accurate as I can. This is just to be considered a sketch, folks. You should be doing this, obviously, with a lovely ruler and sharpened pencil. But I'm just going to assume here that we are... I'll just get down to there, 0 degrees. Come on, James. And I'll just bring this down slightly. We will say that this is my graph, okay? And I'm going to obviously label the axes of my energy continuum graph, and on the x-axis I'm going to have time. Now I'm not going to give that units in a second. It's ultimately going to be in seconds, but it's kind of not it's not a proportionate axis. But up here we are going to put the percentage contribution ATP. So what we're saying here is that the more a system is sort of at the upper part of this graph, obviously the more predominant it is, the more energy it is resynthesized in the form of ATP. So let's start here. I'm going to go off to let's go for some kind of pinkish color. What I'm going to do is I'm going to say we have a system which at the beginning of exercise, especially if we start doing something powerfully, it's contributing a lot, but it drops off very, very quickly and levels out to very little. So what we're saying is, if I was to take this point here, a lot of the energy contribution is from this pink system. If I was to tell you that this pink system was the phosphagen system, that would give you an indication that the phosphagen system, as we touched on already, is a very quick release and provides high levels of energy resynthesis, in this case, rapidly, perhaps at the start of exercise. Well, let's take another one. Let's take another curve. I'll go for sort of a blue one here, and I'm going to say that this one goes more like this. Okay, and this one, we're going to call it the lactate system. What we're saying here is that this one has its peak energy release around about this point. Now, what I'm also going to tell you is that this point, sorry, my pen's not working there for a second. This point here is in the region of 10 seconds, and if I was to trace this point down here, this would be in the region of 120 seconds depending on intensity. So what we've got here, in fact I'm going to rephrase, I'm going to claim I never said that a moment ago, and I'll come back to that point in a second. You'll see why. Okay, so about 10 seconds here, we have the overtaking of the lactate system from the phosphagen system at about 10 seconds. However, we have a third system, which I'm going to do in kind of a yellow color. In this third system, the way this one works is it becomes predominant later on, and it is this point here which would be considered about 120 seconds, because this is the aerobic system. So what we should be able to do here is say, right, at 10 seconds, the lactic acid system becomes predominant over the phosphagen system. At 120 seconds, on average, the aerobic system becomes predominant over the lactic acid system. Now, these two threshold points have a name. Both of these would be considered thresholds. We've got a both of these would be considered threshold. We've got one here and one here. So I've got those two thresholds in that. I should have done that in a different colour. But we've got those two threshold points. This one here is actually called the anaerobic threshold. Anaerobic threshold. And this one over here is actually called the aerobic threshold. The aerobic threshold. But what we can say is at any point on that graph, any moment on that graph, of course, what we've got here is we've got one system that's predominant over another one. Okay, let's take this a little bit further. I now want to take our three systems, pink, blue, and yellow. I'll try and use those colours consistently. So for my pink system, we have got the phosphagen system here, okay, the phosphagen. We're going to look at this in its sort of chemical structure in future tutorials, so you might have watched those already, you might not, but I just want to sort of describe how this phosphagen system works. First of all, it releases very high intensity energy. Of course, if it's very high intensity, that's one of the factors for energy continuum, which one's predominant. If it's very high intensity, it's a phosphagen system. It powers exercise up to 10 seconds. Think about certain athletic events. Think about certain very powerful movements. Also, it can recover 50% recovery in 30 seconds. Now, that's going to become important in a second. And it takes, for 100% recovery, it takes 2 to 3 minutes. So this system, which is anaerobic, actually recovers in 2 to 3 minutes, but we can get 50% recovery of it in 30 seconds. Therefore, we have a work relief ratio. And if you're not sure what this is when we train the system, how much work in terms of time we're going to do in relation to how much relief we're going to do. And we're going to say that for the phosphagen system, for every 1 unit of time we work, we're going to have 3+ units of rest. So imagine that we work for 10 seconds, that's going to mean 30 seconds recovery or more. And that's what we mean with the phosphagen system. Let's take this a little bit further down here. Let's look at the lactate system, or the lactic acid system, also known as the glycolytic system, also known as the lactacid system. Lots and lots of names for these things. But this system, it's not very high intensity exercise, but now high intensity. That's what we're referring to here. It can be predominant for up to 120 seconds as seen on the curve. It takes 5 minutes for recovery, so recovery is in the region of 5 minutes, and our ratio, our work relief ratio, we are looking at 1 to 2. So if we're working this system, for every time unit of work, we do double the recovery of that. And then finally, was it blue? It was pink, then blue, then yellow. For my yellow system, which was going to be the aerobic system, we can just look at the same sort of principles, okay? Here, we're talking about moderate intensity. Okay, so it's sort of longer duration, moderate intensity, not high intensity, in other words. We often use the figure of 2 hours duration. Now, the reason we say 2 hours is that's roughly how much glycogen is stored in the body. There's no recovery required. The aerobic system has no recovery systems required. It's only anaerobic systems that have to recover. And for that reason, our ratio of work to relief, if we were doing something like aerobic interval training, we would do something like 1 to 1. 1 period of work to equal period of rest. Put that into the context of circuit training. If you did 75-second stations, you would do 75-second rest because it would be more aerobic in its nature. Okay, I hope that's useful for you. That is energy continuum. Cheers.